We're going to start off by talking about expressions and a little bit about equations as well. So let's talk about some of the identities that describe expressions. So this right here, if I'm talking about the identity property, that means that the number keeps its same identity. So anytime I multiply by 1, that's this right here, multiply by 1, a number stays the same. So 8 gets to keep his identity, who he is, because it equals 8. Okay, so an equivalent expression would just be 8. Another example of the identity property is adding 0. So if I had 8 plus 0, my answer is just still 8. It keeps its same identity. Commutative property, that means I can switch the order of my numbers. So if I wrote 3 times 2 times 6, that would be equivalent to 6 times 3 times 2. Because 6 times 3 is 18, times 2 will get you the same answer as 3 times 2 times 6. Okay? All right, the associative property, that means I can change up the grouping in my numbers. So here we have 3 plus 2 in a group. If I change that up, if I wanted to do 6 plus 3 in a group and add 2, I could do that. I would get the same answer. Over here, according to GEMDOS, I would do this first. I would get 5. 6 plus 5 would give me the same answer as 6 plus 3, which is 9, plus 2, I'd get the same answer. All right, the distributive property, this one's fine. This is where I get to do the double rainbow. So this means 8 times x plus 7, but really I could take that x and I could multiply it by each number inside the parentheses and keep my addition sign and get the same expression. So if I did 8 times x, I don't know what x is, so I just have to rewrite it as 8x. Keep my plus sign, and then 8 times 7, which is just 56. And if you want to double check, you could always just plug a 2 into the x and solve each expression to see if they're equivalent. All right, this down here should say the reciprocal of a number results in a product of 1. That might sound like a bunch of nonsense, but I promise you've seen this before. Reciprocal just means you're flipping the number over. So if I had 1/2, the reciprocal would be 2 over 1. I just flipped the 2 and the 1. Now, if I said, what's the reciprocal of 3? You might be like, well, there's nothing to flip. I don't have a number under there. But remember, every whole number has a secret 1 underneath it. So the reciprocal of 3 is actually 1/3. So when I say product of 1, that means something that multiplies together to get 1. So if I multiplied this product by its reciprocal, so 6 over 5, I would get 1, okay? Because 5 times 6 would be 30 over 6 times 5, which is 30. When I simplify that, it just equals 1 over 1, or just 1 whole. All right? Or I could cross reduce. 5 and 5 reduce to 1 because I divide them both by 5. 6 and 6 become 1. Now it's just 1 over 1. Okay, so when I multiply something by the reciprocal, my answer is always 1. All right, prime factorization. When I do prime factorization, I'm really breaking down a number into its only prime factors, and then I write my answer with exponents. So for example, I could do 160. Now the first thing that comes to mind is 16 times 10. Okay, so I just broke it down into two things that would multiply together to get that number. Okay, 16 I can break down even further because it's not a prime number yet. So 16 I could do, let's do 4 and 4. 4 times 4 is 16. Now I can't, those are not prime numbers, so I have to keep going. So for 4, both of them are going to be the same. I'm going to do 2 times 2. Same thing over here, 2 times 2. Now those are all prime numbers, so I'm going to circle them. Okay, now let's do my 10. I could do 2 and 5. 2 is already prime, yay. So is 5, so I'm done. So I could write it out as 2 times 2 times 2 times 2 times 2 times 5, but that takes forever. That's why we have exponents. So really what I'm going to do is I'm going to say 2 to the power of, since I have 1, 2, 3, 4, 5 2's, times 5. That's my prime factorization. Okay? All right, let's try 84. 84, if I broke that up, let's do, so I know that 2, that's an easy one because I can circle it, times 42 is 84. Sorry, guys. All right, so 42, that's not a prime number yet, so I have to break that up even further. So let's do 2, another prime, and let's do 21. All right, and then 21, I can break that down by 3 and 7, and those are both prime. So my answer would be 2 to the power of 2, because there's 2 of them, times 3 times 7. All right, there we go. That's prime factorization. All right, over here, an expression versus equation. The big difference here, an equation includes an equal sign, and it has something over here and something over here. Looks like a little face. All right, so an example of an expression is the difference between a number and 12. So it might look like this, the difference between a number and 12. Or I could say the difference between a number and 12 is 9. That becomes an equation because I have the difference between a number, which we're just going to use x, and 12 is 9. Now I have an equal sign, and I have something on both sides of the equal sign. Another example of an expression is 4 plus 13. So we could just solve that, or I could write it as an equation. 4 plus 13 equals 17. All right, here's another example of them as representation. So here I have x plus 1, 2, 3, 4, 5, 6. So x plus 6, that's an equation, or an expression, sorry, because it has no equal sign. Here I have two x's. I can write that as 2x equals 1, 2, 3, 4. That is an equation, and I could solve that to figure out what x would be. All right, next, GEMDAS. I changed mine to GEMDAS because I like the G to stand for groups instead of parentheses, but if you learn something else, that is fine. You can use what works for you as long as you understand that everything grouped together, either in parentheses or brackets, or maybe on one side of a fraction bar, maybe everything in the numerator is a group, and that you understand multiplication and division goes in order from left to right, and addition and subtraction goes in order from left to right. If I have division before multiplication, you do that first. Subtraction before addition, do that first. All right, so example 1. So I don't have any groups, so I can cross off my G. I do have one exponent. Hold on, sorry. One exponent right here, 6 to the power of 2. That means 6 times 6. So what I would do there is just replace it with 36 and then rewrite my problem. So 36 minus 9 divided by 3 times 4. Now I have a new problem. Okay, I don't have any more exponents done there. Let's look at multiplication and division. I have both, but remember, we go left to right, so I'm going to follow. Oh, there's some division. 9 divided by 3. So 9 divided by 3 is just 3, so now I have 36 minus 3 times 4. Okay, I have no more division, but I have to check for multiplication, and I do have some. 3 times 4. So now I have 36 minus 12. Now I just have subtraction left. 36 minus 12 is 24. Okay, next one. Do a different color so we can cross off. This one I do have a group. 8 divided by 2, which is 4. So I have 14 plus 6 times 4 minus 5. Okay, then I'm going to look for any exponents. I don't have any. I'm just going to go ahead and cross it off. I forgot to cross off my G. And then I'm going to look for multiplication and division. So if I'm following along, I see the first thing I see is some multiplication, 6 times 4. So I'm going to turn that into 24. So 14 plus 24 minus 5. No more multiplication. I don't have any division. So I'm going to move on to addition and subtraction. The first thing I see is addition. So 14 plus 24 is 38 minus 5, 33. All right, so that is what your paper should look like for expressions.